Let me just set up a stopwatch, because as was mentioned, a 20-minute talk, what I was saying earlier was I can't even say hello in 20 minutes. So thanks a lot to Uber for inviting me to come give this talk. I'm real happy to be here, and I'm real happy to look into this subject. I've been giving a lot of talks about sort of larger scale issues, the field of data visualization, the profession of data visualization, a lot of sort of theoretical talks and things like that. And when I was asked to give a talk about design and given 20 minutes, I thought, well, something that would be different for me that I'd like to really get into would be to just step through how I designed a particular data product, an analytical application that we've used at Netflix and that has had impact. And so I'm going to go very sort of narrow focus. We saw in the last presentation, you know, a sort of broad sweep of applications. This is literally a single application that's in production at Netflix that we're using to find insights. So before I start, my name's Elijah Meeks. I'm a senior data visualization engineer. I'm the author of D3JS in Action and a charting library called Semiotic, a React-based charting library. I also, as was noted, make funny tweets. I've done a lot of fancy data visualization, a lot of complex data visualization at Netflix, and earlier when I was at Stanford doing data visualization for research. So the map on the left is one of these maps. This is the level of maps that we have at Netflix. It's not quite the same as Uber's maps. And then, you know, a network diagram, those kind of things. But what I wanted to talk about today was a single product that we built called Pathfinder. That product was built to answer a simple question, right? How do people move through the product? And by the product, I mean Netflix. You know, when you're going to go watch a movie on your phone or on your computer or on your television, how do you get to that movie? Do you go through search first? Do you go browse through the rows to find the genre that appeals to you and you select something? And if you've followed me, if you've come down to Los Gatos for the talks we've given down there, you might think, well, didn't you build something like this roughly 3 years ago? Because I gave a talk about this about 3 years ago when I first started at Netflix. One of the first things I built at Netflix was a data visualization that doesn't apparently show up on this monitor very well because the edges between the nodes are light gray. But it was a data visualization using a Sankey diagram that showed how people moved through Netflix. It was a super complex, technically sophisticated data visualization, ran on a lot of data, and allowed you to go and query and filter through and analyze how people were moving through the site. I think of it as the site, really the product, because they're using these different ways of accessing Netflix. And it was technically quite sophisticated. I was very happy with it. It integrated some new techniques for a Sankey diagram, which is this flow diagram that I'll get into later. But it didn't have much adoption because it was so technically sophisticated and abstract that it was challenging for stakeholders to use it. And so eventually we retired this application. Now, I do want to focus in on sort of like that not all data visualization stories are success stories, right? That sometimes we make something that doesn't get adopted, that has barriers to entry, and that's a part of the design process is not only going back and maybe adding edges that appear on the monitors where you're presenting, but also going back and revisiting these problem spaces and addressing the issues that your users had. So instead, when we looked at paths through the product, we used a different kind of data structure, what's known as a hierarchical JSON structure. So hierarchical data is a particular kind of data, like network data or tabular data. And fundamentally, it's a network, but it's a network with a single rule, or with one major rule, that any node on this network, any point on this network that you visited on a site can only have a single parent. So it nests going up. And it's used to represent a lot of different things. In this case, this is actual live data from this application. What we're seeing at the very top, that circle at the very top, is when you start the application. And then from the start of the application, you're going to start the application. Maybe you're going to start it on the home page, or maybe you're going to start it on some view that you were already in when you were at Netflix. And what happens with hierarchical data structures is that it promotes an approach to hierarchical data visualization that people, when they think about designing data visualization, they get into this mode. Again, these links are not showing up very well on this monitor. I guess that's why you guys use such dark data visualization all the time. Now I finally figured it out. But what people do when they end up with hierarchical data is they start to think that the design process is picking one of these hierarchical layouts. So we have a dendrogram, like I was showing before, and that's what this is, a dendrogram, a tree diagram, something like that. We have it projected in a radial way on the bottom right. Maybe we have the same data represented as a circle pack or a tree map. And this really isn't much of a design process. Like, these different hierarchical data visualization modes are suitable for different kinds of data. And picking the right one isn't really a job, right? That's something that you can figure out pretty quickly. What you spend your time on when you're building data visualization is in taking the layout, the charting method that is suitable for your data. In this case, taking that dendrogram, because we're talking about paths, we're talking about movement through the site, and the paths are apparent in somebody sort of stopping at one of these circles and moving to the next circle and so on and so forth. And as a designer, dealing with that data in such a way that it is accessible, that people are going to use this application, they're going to find it useful, and they're going to find insights within the application. And the first step in that is to remove data, to exercise editorial control on the data and find some kind of way of taking something that's already super complex and reducing it down to a structure that is still complex, but at least is going to be accessible for people reading it. So this is using some kind of threshold. You've got a marginal probability that somebody's going to get to some point in their navigation. And after that, you cut off any further navigation through the site from the data set. So when you have a diagram like this, when you have a network diagram like this, there is a sense of, like, you don't want to get rid of any data there because you're going to remove some kind of critical piece of data. You're going to remove it from what your stakeholders are going to use to analyze it. However, in a lot of network diagrams, there are what are known as implied nodes. So at the very top of this, we had this node that we call app start. Like, everybody started this app, and then they started this app at a certain page. That's the next step. We don't need that node, right? You can get rid of it. All it's bringing with it is a lot of visual noise. This principle applies also if you're doing other kinds of network visualization, especially in social networks. There's something called an ego network, which is all of the people who are connected to a single node, all the nodes that are connected to a single node. Well, when you show an ego network, you actually don't have to show the person from which the ego network is derived. In fact, all you're doing when you're showing that person is doubling the amount of lines that you're showing on screen. So again, this editorial control, and then applying color. And color is something that I've been deeply interested in, and color is super challenging, because when you talk to data scientists who are your stakeholders, or you talk to analysts who are your stakeholders, and you ask them, well, how many different kinds of pages could somebody ever land on at Netflix? They tell you, well, 137. And you're like, wait, how can there be 137? Well, there's this flavor of playback, and there's this flavor of movie details, and there's this flavor, whatever. And you can't come up with 137 color scheme. So a lot of data visualization folks that I talk to spend a lot of time and energy and tears trying to come up with the 30 color palette, right? Or the 20 color palette. There is no 30 color categorical palette. There's no 20 color categorical palette that's going to be useful in a data visualization like this that's already visually quite complex. So you have to actually, in that design process, push back and convince your stakeholders to come to some kind of summarization, categorization, roll-up that approaches that 7 plus or minus 2 categories. So here we apply some colors. You take those colors, and another aspect of applying colors is that you can oftentimes, in a network visualization like this, apply those colors to the edges. You know, we get a data visualization mode like this, and we start to think, well, there's things that we can put onto those edges. We can make those edges thicker. We could make them brighter. We could make them darker. When it comes to things like, you know, the map visualizations we've seen here, the edges, the lines are the only thing that you're showing there, really. I mean, all of the points are basically getting blended into a single line. But when it comes to something like this, you're already challenging your user with a complex topological structure. And the last thing you want to do is say, on top of the complex network features that you have to analyze and figure out here, I'm also going to put some thickness on the lines and maybe add some heat mappy colors to them. And a general rule that I follow when it comes to hierarchical visualization is to inherit the source visualization. Because what it does is it helps to re-emphasize the color. It gives them a little bit more color to see so they can analyze and easily categorize the patterns that they're seeing. Now, one of the challenges is that this visualization, this application, wasn't designed just for how people move through the site. Visualization was designed for how people move through the site as they are members of an A/B test. So I assume an audience like this is familiar with A/B testing. Companies like Netflix and Uber, they change the experience somewhat, and they see if the different experience has a beneficial effect on some measurable variable, right? If we adjust the way that the Netflix application presents shows, if we change the way that the shows preview with maybe some short form content or something like that, does that make you more inclined to watch or less inclined to watch? And so you end up with a situation like this where you have a test that has 6 cells, and you have to see not only the structure of how they're navigating through it, which, like I said, is already very complicated, but you also have to see whether or not a particular cell was a success or a failure. And maybe you can start to squint and say, okay, I can start to see some patterns here. Hopefully not, because this is actually randomized data, because this was a very early draft. But as soon as you get any more complex, you can see there's a lot of occlusion, there's a lot of overlap, overdraw, and it's just a mess. So one thing that you, as a designer dealing with data visualization, have to recognize is that even though you might see examples of a data visualization online, that's not the way to do it, right? That's an example oftentimes of how the software works. So one thing that we started to do early on was to squarify those edges, because it makes it a little bit more readable. You can start to see in this data set that if we pass the edges out and then down, what's called a step interpolation, that you can start to read it a little bit better. You can start to notice patterns like happy paths and bad paths, right? You can see that the nodes have changed dramatically because now the amount of edges and what's being drawn underneath them has increased in size. But the problem with that squarifying those edges is that, again, it's harder to see here, but you can see it when I have sort of a toy example, we start to lie with the data visualization. You can see that by squarifying the edges, if you look, and by edges, I'm sorry, I say edges over and over again. Edges just mean the connections between the circles. That just means that something's connected to something else. Edges, you'll hear them called links. The lines that you see now are actually not telling the truth. If you look at the orange in the middle here, and you go to the purple and down, it looks like the purple connects to the green, and then the green connects with a purple link to the orange, and then a purple link connects that orange to the next orange, and so on to the gray. And and it's more clear if you change the step interpolation to a slightly different step interpolation. There's different ways, right? Do you want it to make that right turn before, or do you want to make it after? And again, we can see over here that it looks like this purple, this light violet, whatever color this is. Right, there we go, lilac. It looks like it's connected to this orange node here. And like it's trivial to say, oh, well, it's not. Like, get used to it, it's not, right? You can say that to people all you want, and you can maybe even browbeat them into agreeing with you in a meeting. But really what you're doing is you're presenting a lie or incorrect data again, and I have to emphasize this, in an already complex chart. So ultimately what we ended up doing, and this is getting closer and closer to the final product, is we took the edges as they go out and down, and we realized we don't need the edges that go out. So instead we just stretch the node all the way out, right? We stretch the step all the way out, and then we just waterfall down the connections to the next steps. And this becomes a lot more readable. These are what we started to refer to as barbell nodes. This was a suggestion from Susie Liu, who I work with at Netflix. Ultimately, though, the barbell node causes its own problems, especially in data sets that have a lot of cells. The final version of this, and this is what we're using in production now, what you'll see is it steps down for a second. So we've gotten away from that barbell node, but now we still have a node that's stretched out and then flows downward. And you'll see that edge colors are back, right? out of necessity, because now we still have to encode, was this a successful path, green? Once I get down this path, am I more or less likely in a statistically significant way to perform whatever measure it is that we think is important? But we're at a point where we're only coloring the edges 3 different colors, right? Not statistically significant, statistically significantly better, statistically significantly worse. And what I'm not going to get into is the challenge of finding a red that doesn't conflict with the other colors that are being used as categorical colors, which is a pain. And so you can sort of contrast what an out-of-the-box dendrogram would have looked like, right, if you just sort of cloned an example from D3, with what this much more sophisticated and you know, takes time to build kind of chart ends up looking like. And all of this, this was all built with Semiotic, this charting library that I created. But you could do this with anything, right? This isn't some kind of special tool that I'm using. What I'm using is an awareness and a willingness to admit that when I'm showing things that are super complex, I have to spend time to adjust all these minor details so that it becomes much more effective. Now, we needed a legend because you saw that there were no node names. I wouldn't want to put labels on something as complicated as that. It would make a mess. So we put a legend up at the top. And the legend up at the top, this legend is very uninteresting because I'm not giving you any of the names from the actual data. But the legend at the top ends up telling you whatever that color corresponds to, right? Which step in your navigation does that color correspond to? And then it's also showing some summary information, right? Because what gets lost in this hierarchical view is how many people are going from this step to that step, regardless of when they're going to that step. So we add that to the legend. And we add that to the legend using mechanisms designed to tell you this is not an exact representation, right? These are arrows. The arrows aren't meant to be, you're not meant to measure the arrows and get some kind of analytical information out of that. So again, you can now look at the chart and you can see that, oh, the orange coming out of the purple, that's because most of the time when you're at purple, you're gonna go to orange, right? Purple to orange, purple to orange, purple to orange, and sometimes darker purple to orange. And then once you're at orange, where are you going to go from there? And that kind of thing. And that's also important, is to provide legends. People have said this over and over again, right? It's become more common. Provide legends that themselves transmit data, right? Now, we experimented with other ways, more measurable ways of doing this kind of legend, but what we found out was that you're putting a lot of squares and rectangles on screen. And if you make it with circles and arrows, this sounds kind of silly, right? But if you make it with circles and arrows, then people are going to be in slightly different modes when they're looking at the legend versus looking at this hierarchical viz down here. So this is actually, this is what the application looks like when you're looking at some A/B test. And we introduced this application and people were real excited about it. And then they said, well, wow, but what about people just moving through the site generally? Not in the test, we just want to get an overview of the site. And oh, before I get into that, and I'm running out of time, you'll notice in some of these earlier slides that they're not just these sort of really convenient, clean steps, right? Like a hierarchical data visualization typically has. That oftentimes it's stretched out. And that's because we also have a view that gives you the time to reach that point. So it's not just important that you went from this step to this step to this step. How long did it take you to get there? And the way that I ended up stretching it out is I used this layout called D3 Flex Tree. D3 Flex Tree allows you to create nodes that are of some significant length. The great thing about D3 and the model that D3 presents is that it doesn't force you to use those nodes, and I didn't. Instead, what I did was I used those nodes to make the layout, but then from the layout, I still drew lines. So underneath, when I'm calculating this, there's a giant rectangle here for the node, but I only draw the node up at the very top of that rectangle, and then I draw the line all the way down. When we got asked to do this to look at the entire site, we started to say, well, where are the cycles in the navigation? And to get into talking about cycles, we have to use a different kind of chart. We come back to Sankey. There's a Sankey implementation now that has cycles in it. And unfortunately, I mean, and it's proved useful. This is, again, real data, and you can see how people are going from some particular step, and they're going back to another step. But these are challenging diagrams, and they can get really complex and really messy really quickly. However, we should use them as much as we can. Because the reason why these are challenging, why the layouts maybe aren't the most optimized, is because people don't use them. And so it's this chicken and the egg question. If you don't have implementations, then you don't have suggestions on how to make it a stronger algorithm to have better performance when you're dealing with more complex networks. And so ultimately, this is what the other view looks like. So this is this overview tab. And what it shows is it shows navigation down out of a particular page or area of Netflix, and also what are the steps that typically led to that page. And then it shows the cycles at the bottom, it shows the legend up at the top. And what's really cool about this is, like, this is super complicated. Remember, I started this talk by talking about how, like, I spent my time in blood and sweat and tears and lots of tears, and I made something that I thought was really cool and nobody used it. Instead, this time we showed it off, and then, you know, we started in one area, and then they said, well, also add this. But now, you know, we're getting contacted by people who are not only in the product area of Netflix, but in the content area of Netflix, in the technical, there's folks who are looking at this to try to optimize how they're hashing data structures. And there was a lot of enthusiasm for it because of this time that was spent, that was invested in making something that wasn't just sort of out of the box, that wasn't in love with its own complexity, and it was really focused on how people are going to read it. So the last thing I wanted to mention is that, like, why do we spend the time and effort? Why do we try to convince people to use complex data visualization? Well, that's because it's not just complex for its own sake. It's that what you're showing is a kind of data that is fundamentally different than tabular numeric data. And so the people that you're building data visualizations for, whether that's yourself or other stakeholders, they can't make decisions about things unless they can actually see those things and not some boiled down version of those things. The quote that I think is really apt in this case, which is, you can't measure what's important, you make what's important count, right? So until you start to develop views that are views of topologies, that are views of hierarchies, that are views of flows and paths, then people aren't going to be able to make decisions based on how people are flowing through the product that you're developing. This is a tweet that came from Stephanie Posavec yesterday, IO tweet, and I thought it was particularly apt. And that's what I got. Yeah.